Welcome back to a lecture series on geographical information system, practicals related to map registration. So, in this practical, now what we are going to discuss about the registration. Registration, in a very simple sense, if you want to express taking the printed map, dropping over the surface of the earth, it means you are now taking the all corner points or the distributed central ground control points into the real earth system. Then what will happen once if you just drop it over the ground surface, you will get the real informations. That's the map registration. Map registration, if you want to define exactly unregistered map, you are taking the coordinates and fixing over the surface of the earth. So it is there in the geographic georeferencing tool. There are 4 steps. We will see every steps in detail. The first step like add point, rectification, and WGS, UTM, and we will see one by one in detail in the georeferencing tool. Right, everything which is available at the right side catalog is shown, and so all these informations you will see. Once if you open the ArcGIS, the window will open. You have to add the map. Normally the scan map in the form of a TIFF we are now adding. It means bringing into the map window. So you can zoom it and see the scale. It is 1:50,000, and you just look at the latitude, longitude details. Lat 75, 45, 13, 30, and now you just zoom the right corner, zoom to the maximum level. Of course, I have done this is for the practical purpose. Zoom level is very less. Normally, if you do any mapping, you zoom to the maximum extent. You take down your information in the note and then type it later. So now we will have to take georeferencing tool in ArcGIS. So how to take, you just right click on the top and then select the georeferencing tool. This will come because the map is enabled, everything is enabled here. Map also selected here, topo sheets. The first step we have done already, adding now we have to do first step, adding XY coordinate, and this is the button which we use, add control point. So this button we have to click here. So this button add, and here you have to click, and before that we should know how to convert the degree minutes into degree seconds. Normally ArcGIS will take degree seconds, degree decimal. So you will have to convert the degree seconds into degree decimal. How you will do, you take as such the degree without any change and then take seconds over 60. So degree is 75 and second minutes 45. Normally minutes, we know that 60 minutes is 1 degree. So we will take like this, 75 without disturbance, and 45 we have to take 45 over 60. 45 divided by 60. So now the value is 0.75. We have to do right click and then right click. Slowly you have to keep your left button, right click. You have to click left button. After coming one, you have to click. You see, no, this will not come. You will get one the symbol with different colors. Like you see, green color one is coming. Then right click. Take input XY. Input X and Y. Here we have to type, enter the coordinates. Here now we are going to type X is 75 and Y is 13 degree. So 45 we are now converting, degree decimal. 45 becomes 75. 45 over 60 and 13, then you okay. What does it mean? It means the first point, then zoom to extent. First point is registered with respect to the exact coordinates in the earth. Now similarly we have to do 3 points. Automatically the 4th point will take on its own by the system. So now we are going to take the same, take the add control point and then click it here, right click. If 2 comes, you right click and then give X. So 76 degree, 0 minutes, 0 minutes, no issue, 76.0. And similarly for 13:45, if you convert, you will get 75 because we have done in the last point. Give OK. Now the second control point is also taken to the real system. The map is now taken to the real system. That's what it is happening. And go to the third point. Normally for the research and all, we used to take all points, almost all whatever the points, and sometimes we also take. Now 30 you have to convert. Take 30. So 30 over 60, it will come 0.5. We'll see 30 divided by 60. Then you just give OK, and you will get 0.5. So now we have to give 13.5. Again take that point and right click. If the number comes 3, otherwise this will come without clicking. Click left and right. Yes, right. Give XY input. Here 13.50. It's 76.0 and 13.50. Okay. Automatically it takes, but a small error that has to be rectified. Now 3 points, automatically the fourth point will generate on its own. That is the system generates. Now you zoom into this level for all points. Take exactly at the center point, right click, give XY, automatically you see 75, 75 and give OK. That's it. Now the map is registered, and you can see at the bottom that when you move, you will be able to get everything. Right? It is now taken. Now first point, step 1 is over. Add XY point. Now we have added the XY points. Now we have to project, rectify the image, the raw image into the georeferenced images. Go to georeference tool, and there is a tool. In the drop down, you take rectify submenu, and in the rectification, you'll be getting save as option. In the output location, you will have to show that where you want to save your data sets. That you have to be very careful. You can set even when starting all your work. You can set which folder you want to do all the work. Right now, JS tutorial registration name, it is coming on its name. This is the name of the file. So TIFF file normally will take in the form of IMG. You drop down and then you have many options. Select imaging file, and in the imaging file you just save. You see at the bottom it is running 6474. Once if the process, it will take 30 seconds minimum, and then now the image is the second second step is now completed. We'll go to the third step, that is WGS 84. So that is the projection system universally accepted by many scientists. Many scientists that now whatever the work you do with this one. There you have to take the file in the catalog after opening. This is the file we will have to now see the properties, that whether the image is rectified or not. Now you see the images, and here we have to edit, and then you see in the spatial reference, and you look at that it is GCS Geographical Coordinate System 1984, but the zone we have to fix. This will be there in the Geographic Coordinate System. There are many projection system, Geographic Coordinate System. Again, if you take, we have many, and you take world. In the world, you will have to take the WGS 84. So this is how we have to now select everything, and WGS 84 catalog. Now we have to open the WGS 84 to fix the zone. The zone, because it is there, GCS WGS 84, apply OK. Now we are now going to convert this into universal transverse Mercator coordination. That is your reprojecting raster projection tool. go to our catalog, our toolbox. In the toolbox, everything is there. Nearly for about 300 plus operations which you can do with your map, it is there. So we have to get more familiarized with this in this using all these tools for our study. So you take projection in data management tool. There is a sub tool called projection and transformation. In the projection, again there is a tool called raster data. Now we are doing with raster data. So project raster, we have to double click the project raster projection tool. In the raster projection tool, we have to double click. It takes a few seconds. Now the new pop-up icon will come. In the new pop-up icon, yes, it is here. This is new pop-up icon. The input raster file, as we know that we have to take it to the imagine img file, which have already done the illustration work. Third step, not TIFF we have to take, we have to take img file. So now the image is selecting. It takes few seconds. Now it is taken, and then output also it is set automatically, and the file name is project raster. You can change the file name as rectified. Now you have to keep. Now the file is saved in the name of register.tif. Now you have to give the output coordinate system. So output coordinate system in UTM, we should know how to fix our zones. What zone it is our, suppose it is divided into 6 minutes interval. We'll see. UTM you take. In the UTM you go down WGS84. If you click double click the northern hemisphere, select northern hemisphere, and here if you are thorough in selecting the zone, no issue. Otherwise you also can find it out what zones will come for your study. That also we can do. We'll see one by one. Now go to the degree minutes zone on the top left to find what zone it is. 75 degree, and you also go to the right hand and check what is the degree. It is 76 degree. Now we will have to find what zone this will come, because in this projection they have divided the whole world. I mean, it is mapped like 6 minutes interval. So the only hemisphere we are now taking degree divided by degree into degree into 1 minute. I'll just show you. I'll take the toolbox. Degree 75 into, it is because it is only the half zones it is taken. 75 degree into 180 divided by 60. Just I have not typed this, I am just writing now. 75 degree, sorry, it's not, I could not be able to write properly. 75 degree plus 180 divided by 6. Because 6, what does it mean? It means every 6 minutes interval one square is taken. So it's divided like that. So we have taken the half sphere. The map is projected like this, 6 minutes interval. Now you see, you can look at this. This is good because you see 75 degree. We have taken the left part plus 180 because half hemisphere divided by 60. 6 because every 6 minutes. So my zone is 42.5. Similarly, for the other end, you have to take average of it on the left side and right side. So it will vary from place to place. Now this is for the left end, and for the right end also we can calculate. Now it is 75 on the right side. You look at the right side. Right side it is 76. Yes, if I am correct. Yeah. Now 76 cancel 76 plus 180 because the segment is divided, the arc segment. If you take the whole Earth, it is in two sheets, 180 plus 180. Now we are taking only one part of the study divided by 6. So 42.6 there, 42.5, 42.6. So no issue. So it is between 42.5 and 6. So it means it is 43. Now we have to select 43. So go to projected coordinate system, and UTM WGS 84 northern hemisphere, and here we have to select the zone. 43 is mine area of work, so I am selecting 43. Now give OK. Give OK. Now the map is reprojected. After the reprojection, the map is now set for your further work. Now map is registered exactly with respect to the real system. That's the process what we have done. We have also raster reprojection is done, and then now the map is ready. And now go to window. Sorry. Now you see the result. Projector raster. You just click the current session. You can also check your results whether it has come. Now projector raster has come. Now with this the projection system. Wait 1 minute. Yeah, you see, if you double click, it will automatically come. So this is the projected map, registered one. This is TIFF file. If you remove and then bring this to full extent, now you see, yes, now the map is registered exactly and reprojected with UTM. Now you look at that 7547. If I am just moving the cursor near to that, yeah, yes, I am getting 75, 45 and 1345. Yes. What does it mean? It is exactly draped over the surface of the Earth. So with this, the current lecture on registration is come to an end. Thank you very much.